Hello friends, welcome to GoodTecher LeetCode tutorial. Here we are going to solve largest rectangle in histogram coding problem. So, given n non-negative integers representing the histogram bar height where the width of each bar is 1, find the area of largest rectangle in the histogram. So above is an example histogram where the width of each bar is 1, given height that's an array of integer 2, 1, 5, 6, 2, 3. So each number indicates the height of each bar. So this example histogram, the largest rectangle is shown in the shaded area where it has an area of 10 units. So we see this rectangle, the shaded area is a rectangle. So this rectangle has a height that's 5 and the width that's 2 because there are 2 bars. 5 multiplied by 2, that's 10. So that's 10 units. So this coding problem, we are going to have an input that's array of integers. Our output is an integer value indicating the largest rectangle area in the histogram. So I'm going to talk about this largest rectangle in histogram coding problem because I saw there's a friend called Lawrence leave me a message on my website GoodTecher.com. So this friend Lawrence wants me to take a look at this largest rectangle in histogram coding problem. So here we are going to take this friend Lawrence request this challenge to solve this largest rectangle in histogram coding problem. So here we have this example input that's an array of integers 2, 1, 5, 6, 2, 3. So with this input array, we can imagine such a histogram. So with each number indicates the height of each bar. 2, 1, 5, 6, 2, 3. That's height of each bar. So our goal is to find the largest rectangle area among this histogram. So we can introduce a variable called max area. We know that's an integer value. So max area. So there are many approaches to solve this coding problem. The approach we are going to use today is an approach by introduce stack. So we are going to introduce a stack. So stack is a first in, last out data structure. So with a stack, we can store the index of each bar. So with the stack help, storing each index of each bar. So with each index of each bar, we can easily refer to the height of each bar because we see this is an array of integers, and with the index, we can refer to the height of each bar. So at the beginning, we are going to push a -1 into this stack. So -1, you can just think of there's a -1 index before the 0 index. Here, you can assume there's a dummy bar here. So with this dummy bar, it would be helpful for us to solve this coding problem. So we are going to push this -1 index into the stack, and then we point our index to the 0. And find that the current bar height would be the 2. Because this index 0, the bar height is a 2. So we are not going to compare this bar height with the dummy bar. So just directly push this index into the stack. So now we get the 2 index into the stack. And then we move to the next one. So index is 1. So the height, this bar, would be the 1. So here we would have a condition to compare the current bar height with the top element of the stack. That's an index. So what's that index bar's height? So compare whether this current bar height is smaller than the heights. So heights is that origin array. So heights and the index would be the stack.p. Stack.p is a top element. in the stack. That's the index value, and we use that index value to get that bar height. So we compare whether this current bar height is smaller than the stack.peak's bar height. So we compare. So current index is 1. Current index is 1, and the current bar height is also 1. So 1 is smaller than the height.peak. So that's this index. So 0, the height is 2. So this height would be 2. So match with this condition. So we can go to a condition block. So condition block and the height. So now we can use would be the 2. So this one, the previous one is a taller bar. So that's 2. 2. How we get this one? That's we just pop over the top element of the stack and refer to the original array to get that height. So that's height.stack.pop. We get this 2. And the weight. So the weight would be the I. So I minus stack dot peak and minus 1. So here the last one would be 1. So here we see the current I is 1 and minus. So this top element already being popped out of the stack. So the only index we here is a -1. So 1 minus -1 minus 1. That would be 2 minus 1. That would be 1. So width is 1. So area would be just this multiply the height multiplied by width. That would be 2. So that's just a first bar. First bar, it's a rectangle and its area is 2 compared to the previous max area. At the beginning, max area just 0. So this area would be updated here. So that will be the 2. 0 becomes a 2. So that's a current max area. We get that that's a 2. And remember, after that, we need to stack down, push the I into the also to the stack. So we push this index, that's 1, into the stack. Then we can move to the next index. Next index, that's 2. So that's 2. That's 2. And we compare this current bar height. So this current bar height changed. So this is a tall bar height. So that's a 5. That's a 5. 5 is greater than the previous this index 1's bar height. So that's so this condition doesn't match. So we can directly go here. So skip this condition block and stack dot push this I. Push this I, that's 2 into this stack. And then we go to the next one. Next bar. That's index is 3. The bar height would be the 6. So current bar height is 6. 6 is also checking the top element. That's 2. Index 2's bar is 5. 5 is smaller than the current bar height. So current bar height greater than the previous bar height. So we didn't match this condition. So we need to skip and push this current bar height, current index into this stack. And then move to the next one. Move to the next one. The index is 4. So current bar height changed. So current bar height is current bar height is the height dot I. So here current bar height, the I is 4. So 4 and the height index is 4. So the height is 2. Height is 2. Height is 2. Smaller than this peak element's height. So 2 is smaller than 6. 2 is smaller than 6. So we can go to this condition block. So the height, let's change. So this change to 6. So change to 6. The height dot stack dot pop. So we need to pop this element out of the stack. And then check this use this formula to calculate the width. So calculate the width. I is 4 minus peak. Peak is 2 minus 1. So that we get 4 minus 2, 2 minus 1, 1. So 1 here. So width is 6. So area is we get here, it would be the 6. 6, just this bar itself is a rectangle. And this compare with the previous max area. So 6 greater. So we update the max area. So that would be 6. And here, this condition actually is a while condition. While this condition is still matching, we should still execute this condition block. So here, the current bar height would be still at the index 4, that's 2. But the stack dot peak is changed. So stack dot peak is 2, index 2, and the index that's 2, and the bar height is 5. So here change. So that's 5. And the height would be pop from the stack. So this is 5, and we also pop this element out of the stack. And the weight also needs to recalculate. So here, that would be the I is 4. 4 minus stack dot peak. Stack dot peak is 1. 1 minus 1, that's 2. So width is 2. Height is 5. So area would be 5 multiplied by 2. That would be the 10. 10 is greater than previous max area. So we also need to update the max area to the 10. So max area is 10 now. And then we check current bar height, that's 2, whether is still smaller than the stack dot peak's height. We see this stack dot peak is 1, but that height is just a 1, so it's a shorter one. So that one, this condition doesn't match. So here we are going to push this 4 index, skip this block and push the index 4 into the stack, and move our index to the last one. That's index is 5. So last one, index is 5. So here we check the current bar height is update. The index 5, the height is 3. And we compare whether this condition works. So current height is 3 now. It's 3 now. It's 3 now, but is greater than the 2. It's greater than the 2. We are not going to execute this condition. We are going to just directly push this index 5 into this stack. And here we already finish stack finish. So this iteration is already finished, and we find the max area is 10. But here there are still some remaining. So remaining of the stack. So we see here there are 4 elements in the stack. So except the -1, all the other index are real one. So here we are going to have a condition to check while this stack dot peak element is not -1. It's not a -1. We are going to have a condition to recalculate the area. So area, so the area, so the height would be the value of the same here, the height dot stack dot pop, and the weight. So for here, the height would be stack dot pop. That would be the index is 5. So at here that would be the 3. So in this one, index is 5. Pop up here, and the weight. So weight is changed. So weight would be the height dot length minus this stack dot peak minus 1. So for here, the stack dot length is always the 6. So 6 minus this 4 minus 1. So that is 6 minus 4, 2 minus 1. That's 1. 1 here. The area we calculate is 3, but is smaller than the max area. So we are not going to update, and we're going to do the next iteration, because stack dot peak it would be the 4, but it's still not a -1. So here, this height would be we pop this one. So the index is 4. Index is 4. The height would be the 2. 2. It would be the 2, and the height dot length is still the 6. 6 minus 1, that's 5 minus 1, that's 4. 4 multiply the height. 4 multiply the height. 4 multiply the height, that's 8. 8, but that's still smaller than the max area. So we are not going to update the max area. So then we're going to just go to the next one. So next one, so we pop this element. So this index is 1. Index is 1. Height, the 1, that's 1. Height is 1. Then the height is just 6. The height dot length 6 minus the peak, that's 7. We get 7 minus 1, that's 6. 6 multiplied by 1, that's max area is 6. Is still smaller than the max area, not update. So here, finish. So this condition. So this is the last one. So stack peak is a -1. So we finish this iteration now. So max area we get, that will be the 10. So see here, so we get this, after this process, we get the max area, that's a 10. So here, let's go back to the coding. So let's coding in Java to solve this coding problem. So here, let's see, the height would be, so let's first have an edge case check. So if height is a null, or height dot length is 0, just directly return 0. Then we can introduce this integer value that indicates the largest rectangle area, so integer max area, and then introduce stack. So stack integer stack, new stack. So as we mentioned, we are going to push a dummy bar. That's the index is -1 at the beginning to the stack. So here we have a condition for each height. For each height, we are going to check the current bar height. Current bar height would be the height dot I. And while the condition, so as we mentioned, while this condition, while the stack dot peak is not -1 and the current bar height is smaller or equal to the height dot stack dot peak, then we are going to do this condition block. So that height would be this is local one, so the height would be the height stack dot pop, and the width would be the I minus stack dot peak minus 1. And here we can have a variable called an area, so that's a height multiplied by this width, and we are going to check whether we are going to update this max area. So just compare this area with the previous max area. With max area. And after this while block, we are going to push the index into the stack. So after this finish, this iteration finish all the value in the height. If this stack still have the value, as we just showed here, if still have some index value in the stack, not just the -1, we are going to have this condition. So while stack dot peak is not -1, so we are also going to do this calculation. Height would be the height dot stack dot pop. This is same, but the width would be the height dot length minus stack dot peak minus 1. And we are going to check whether this area, the height multiplied by width, whether we need to update the max area. And in the end, just return the max area value. So before we submit, let's check if we have some typo. So first, have an edge case check. So height. So if this height array is null or is an empty array, return 0 directly. Then initialize a max area as indicates this for the final return. And we initialize a stack. Stack at the beginning, push a -1 into it. Then we iterate this height array. So the current bar height, we check current bar height is just height this index. The index, get this index and get the value from the height array, current bar height. So while this condition stack.peak is not -1 and the current bar height is smaller and equal to the height.stack.peak. So if this condition works, go into this condition block. So height would be the height stack.pop So get this index and refer to the origin height to get this height. And the width would be I minus stack.peak. Stack.peak minus 1. So then doing this math, height multiply width, and use this area, this calculate area compared with the previous max area. The bigger one, update this max area. After this while loop, we should always push this index into the stack. And while stack.peak is not a -1, so means after all the iteration, if the stack has more elements, not just that -1, so we are going to do this while loop. So height.stack.pop get the top elements that index and find the bar height from the array, and use that height. And the width is height.length minus the stack.peak minus 1. So area is height multiplied width. Mass also we use this mass.max compare with whether this area is bigger than the previous max area. If greater, then we update the max area. So final, we return the max area. So here, let's click submit. Accepted. So very beautiful. Successfully, we solved this largest rectangle in histogram coding problem. So we successfully solved the Frank Lawrence challenge request. So you see, some companies maybe interview you about this coding problem. This is actually a hard coding problem, and it's popularly being asked among some top tech companies coding interviews. So here, just as you see, we use a stack approach to solve this coding problem. So hope you learn how to solve this problem using the stack. So here, thank you for watching. Thank you for subscription to the GoodTecher channel. So hope we keep making progress together. So see you next time. Bye.